Hello and welcome to Honors Function. In this video, we're going to be looking at two types of functions that are pretty ubiquitous in math. The piecewise defined function and the floor function. Let's begin with the piecewise defined function. A piecewise defined function is a function that will be given with several expressions in function of x, of course, if the input is x. So you can have an expression 1, an expression 2, and you may have more than two expression n. And these expressions are true only on some interval of the real number. If x belongs to I1, that's an interval. If x belongs to I2, that's another interval. And finally, if x belongs to In. And of course, these intervals are disjoint. They cannot have any common point, or else the expression, the function, would have two outputs. Let me show you what that means. It may be a little bit abstract. Let me show you what it means. It's very simple, actually, okay? For example, let's take f of x equals, so let's say we have two expressions. It's either 2x plus 1 if x is negative, let's say, and it is x squared if x is positive. Why not? Okay? So what's going on here? Well, what is f of negative 2? Well, where's negative 2? This is your test right here, okay? This is the interval I was talking about. So where's negative 2? Well, negative 2 is not positive, so negative 2 is right here. Therefore, I'm going to be using this expression to determine f of negative 2. f of negative 2 is 2 times negative 2 plus 1, which is negative 3. Where's f of 5? Well, f of 5 is not negative, right? It is positive. So f of 5 is just 5 squared, 25. Okay? Now the boundary here, the boundary is 0, right? That's a boundary. Where is f of 0? Well, you have to be careful this time. Don't look for it in this one, because this is when it's strictly above 0. So you're going to pick it up from this one, and f of 0 is 2 times 0 plus 1, which is 1. Okay, I think this is pretty clear. Look at the problem we would have if the interval were not disjoint. So let me say, for example, if x is smaller than 0, and here if x is above negative 1, you see, that doesn't make sense. For example, what would you do for f of negative 0.5? Well, negative 0.5 would be right here, right? And so you would say f of negative 0.5 is 2 times negative 0.5 plus 1, which happens to be 0. But negative 0.5 is also here, okay? And then you would say, well, it's also negative 0.5 squared, which is negative 0.25. And there you would have two different outputs, and that doesn't make sense, okay? So we want to avoid this kind of confusion. This is not a function, all right? Okay, I think it should be pretty clear. Let's go over one example. All right, example 1, I'm asking you to graph this piecewise function. So you have three expressions, and you can see that the intervals are disjoint. They do not have any common point. They can't, okay? Sometimes the boundary may be common, like I don't know if it works here, okay? And in this case, it better give you the same output if you use the expression on the top or this one, okay? Anyway, we won't go there. Let's see what's going on if x is smaller than or equal to 2. How do I graph that? Hey, I know how to graph that, right? X squared minus 4x plus 7. This is just a quadratic. I'm going to complete my squared. Minus 2. So minus 4 plus 7 is plus 3. Okay? So my vertex is at 2, 3, 2, 3 right here. And then I'm graphing x squared. So 1, 1. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here we go. This is a graph of the function when x is smaller than negative 2. Okay, what's the next interval? Between 2 and 5. So don't do this like, this vertical line right here, but I'm going to do that to show you, okay? I'm between 2 and 5. And I have to graph negative 2x plus 7. So I'm not going to compute any point. This is pretty easy. I'm going to go at 7. So 7 is right here, right? And then I'm going to look at the slope. The slope is negative 2. Be careful. Don't graph anything right here, okay? The function does not exist here, okay? So let me go at 7 and do a slope of negative 2. 2 down, run 1, 2 down, run 1. Oh, I start right here. Now, it doesn't have to connect, but this one will connect. Now, here I should draw an open circle, but because the point is already there, it's just going to be closed, okay? It doesn't matter right here. And then I'm going to do my slope again. So here we go. 2 down, 1 over 2 down, 1 over 2 down. Now be careful what is going on right here. Here it's a closed circle like that. So here's my graph this way. And then the last interval, it's above 5. And then it's a constant function equals to -5. So right here. And it is open at 5, right? So open circle and this way. That's it. And you cannot have a two closed circle right here, or you would have two different output, okay? So pretty simple, right? Let me show you how your calculator can graph this kind of function. It is possible to graph this kind of function with your calculator. Let's take the calculator. Okay, here is a calculator. Let's go to the y equals menu, and you will have to enter 3 different functions, right? Because I have 3 expressions, but I'm going to show you how to represent the domain restriction for each expression. So, put in parentheses your first expression, so it's x squared minus 4x plus 7, close the parenthesis, and right here I'm going to open and close another parenthesis where I'm going to enter the restriction, and this is for x smaller or equal to. So where's smaller or equal to? It's in the test, right? It's a test, so second math, and here you have smaller or equal to, it's number 6, smaller or equal to 2. Here we go, and close the parenthesis. That's it. That is your first expression. Second expression, what is it? It is negative 2x plus 7, so I'm going to open the parenthesis. I think I need to open the first one. I'm not sure. Yeah, I'm pretty sure I need to open the first one. So it's negative 2x plus 7, close it. And here what do we have? So we can't enter a double inequality here. You're going to have to enter AND, okay? So 2 is smaller than x, so 2, and then it's a test menu. Second math, 2 is smaller, that's number 5. 2 is smaller than x, right here, x. And you cannot have, you cannot enter a smaller than or equal to right next to the x. It's a double inequality is a conjunction, it's an AND. AND is also in the test menu. So second test, but it's a logic statement, right? Logical statement. So you go to logical and you grab AND right here. And so AND what? And x is smaller than or equal to 5, so x is test menu smaller than or equal to 5. That's it. Close the parenthesis. Done with my second expression. Third expression, I don't think I need to put a parenthesis here. It's just -5. And this is true for, so this is true for x greater than 5 or 5 smaller than x. So 5, second test, smaller than x. Here we go. And I believe that should do it. So let's check out, I'm going to have a zoom standard, zoom 6 right here. Here we go. That's a parabola, piece of it. And this is a linear piece of it. And this is the constant function piece of it. So this window is not too good. You know, we could arrange it. So I don't need much x negative. So I'm going to go to -1 for the x. X max, well, let's go to 8. It's fine. Y mean -10? No, it's -5, right? My lowest one. So -6 right here. Y max, I don't know, let's go to 8. We're going to see a slightly better graph right here. Yeah, that's a slightly better parabola. And the linear function and the constant right here. Here we go. That's your graph, 3 pieces, okay? All right, I'm done with the first topic, piecewise defined function. Let's move on to the second topic. So guys, the second topic is about the floor function. It's sometimes called, actually in high school, it's always called the greatest integer function, but for a reason I will tell you in class, a couple of years ago I've adopted what is now common to call the floor function in higher setting than high school, and because it really makes sense. It's not because it's a higher level, it's because it really makes sense and the notation is very very indicative of what it is, okay? So what is a floor function? So before we define the floor function, we need to define the floor of a number. What do we call the floor of a number? What is that? So let's take a number x, and the floor of x is something I'm going to write like that, the floor of x, okay? It's not a bracket, it's just a notation. That's a floor of x. So what is it? Well, it's equal to an integer, and I'm going to describe what it does. Such that what? Such that n is smaller than or equal to x, which is strictly smaller than n plus 1, okay? And x is a real number. So we need to understand what that does. What is this? If you take any real number, let's take, for example, x equals, I don't know, let's take 2.6, okay? Let's take 2.6. So this is my x, right? What do you notice between these two? Oh, I didn't tell you, I'm sorry. I'm lacking some information right here with n in z. Okay, now that's clearer, right? Without that, it doesn't make much sense what I'm talking about. N, although some of you may think it doesn't make much sense right now, n is an integer. So if n is an integer, what are these two numbers? Consecutive integers. So guys, what are the two consecutive integers between which you place 2.6, okay? 2.6, you place it between what and what? Between 2 and 3, right? That makes sense, between 2 and 3. And so, what do we call the floor of 2.6? Well, let's see, it's this one right here, the one that is on the left. It's 2. That's it, done. Okay, let's go over the floor of 0.15. Okay, so what are the two integers you're gonna place 0.15 between? So don't forget, here it's always strict and here it's a large one, okay? So you place it between 0 and 1, therefore the floor of 0.15 is 0. All right, let's take another one. How about 3? Okay, what are the two consecutive integers between which you place 3? Now you will understand here why I have my equality there. Okay, that's going to be very important. 3 is placed between 3 and 4, right? And so the floor of 3 is 3. Okay, that's why I need this equality right there. Now let's take a negative one. Negative 3.14. So negative 3.14 is placed between what and what integer? Well, here you got negative 3 and here you got negative 4. So you see right here there's a little like negative 3.14 is not negative 3, it is negative 4. It's the floor, it's always the one on the left, okay? When you look at positive number, the floor is very simple. This is what you do when you want the floor. You cancel the digit after the decimal and you grab your floor right here, okay? Here, the digit is like 0, 0, so you cancel it and you grab your floor. When you have negative number, it's not the same, right? You need to take the one that is on the left side of it. And why floor? Guess what? Because we have the ceiling of a number, which I am not going to talk about right here, but the ceiling of a number is 1. It's a 1 on the right, okay? So very simple, floor, ceiling. So now, how do we define the floor function? So here is the floor function. The floor function, the domain of the floor function is R. The codomain of the floor function is Z. And actually, this is the codomain and it's also the range, okay? It's a codomain. But in this case, it's also the range, all right? And it takes x and it associates to x the floor of x. This is the floor function. So what does the graph of the floor function looks like? Well, what is the floor of 0? Well, that is just 0. So here we go. What is the floor of 1? Well, it's just 1. Okay, so at 1 right here. And the floor of 2 is 2. And the floor of 3 is 3. And the floor of negative 1. What's the floor of negative 1? The floor of negative 1, well, let's see. Negative 1. Negative 1, you make it smaller than or equal to negative 1 and smaller than 0. Greater than or equal to negative 1 and smaller than 0. So the floor of negative 1 is negative 1. The floor of negative 2 is negative 2. The floor of negative 3 is negative 3 right here. All right? That's it. Now, the floor of 0.1 or 0.2 or 0.9 is 0. So here we go. Like that. And here you have an open circle. The floor of 1.1, 1.2, 1.3 is just 1. Okay, so it's constant on this interval. Open circle. Here we go. This is what the floor function looks like. It's like a stair. I think it's also called a stair function, okay? Your calculator can graph this. Let me show you where. So let's go back to the y equals menu. So let me clear this and this and this right here. Your calculator can graph the floor function. You will find it in the math menu. And you want numerical, and it's called int5 right here. Int right here, and just type int of x like that. And let's do a zoom standard, zoom 6, and this is the floor function. So you don't have the circle right here, right? But you do see the stair aspect of it, okay? So this is a floor function. Let's go over one example, and we'll be done with this lecture. So I want to graph the floor of 2x. How do I graph the floor of 2x? Well, let's see. Let's understand what's going on right here. What about if the input, so what do I call the function f? So what is f of 0? F of 0 is the floor of 0, which is 0. So f of 0 is 0, so I'm going to be right here. What is f of 0.25? F of 0.25 is the floor of 0.5, right? Twice 0.25, and that's just 0. So f of 0.25 is 0, right here. What is f of 0.5? Well, f of 0.5 is the floor of 2 times 0.5, the floor of 1, and the floor of 1 is 1. So you see f of 0.5 is going to be right here, right? And what is f of 0.75? F of 0.75 is twice 75 is 1.5, and that is 1 still. Okay, so 0.75 right here. So I've looked at 4 values right there, and I think I should have a pretty good idea now. It's going to go up to 0.5, and I'm going to have an open circle right here. Then from 0.5, twice 0.5 is 1, right? So it's going to be, the floor is going to be 1 until I hit 1, because f of 1 is equal to the floor of 2, which is 2. Which is 2. That's why I have an open circle right here, and here I have a closed circle. Then between 1 and 1.5, between 1 and 1.5, what's the double of 1? 2. What's the double of 1.5? 3. So between 1 and 1.5, 2x is going to be between 2 and 3. So the floor is 2. The floor is 2. And then between, where am I? I'm between 1.5 and 2. Between 1.5 and 2, double 1.5 you have 3. Double 2 you got 4. So the floor is 3 right here. The floor is 3, like that. And then between 2 and 2.5, right here, double 2 you got 4. Double 2.5 you got 5. The floor is 5, like that. And you see what happened? It's like it's shrunk. It shrunk the other graph, and of course we're going to have the same thing going on right here, like that, and this is the same, and then it's going to be closed here and open there, and that's it, okay? So this is my the floor of 2x. All right, done with this lecture. Thank you for watching.